take good notes and ask questions when you have to. All the things. What? All right. If we have a number to the negative exponent, whatever it is, like a to the negative b, that equals 1 over a to the b. Also, if we have 1 over a to the negative b, that equals a to the b. So it changed. So negative exponents, I like to say they change levels. Okay? So if it was on the top, it goes to the bottom and it becomes positive. If it was on the bottom, it goes to the top and becomes positive. Easy peasy? Let's do some examples. Right? The following with positive exponents. All right. So, 2 to the negative 3. We want to write that with positive exponents. We're going to change levels. So it's on the top. So he's going to go to the bottom. And the exponent is going to become positive. So 2 cubed. There's nothing left up there, so we've got to have a placeholder. So 1 will do just fine, right? Easy peasy. All right. Let's do another one. Then we'll do a couple guided practice ones. So m to the negative 4. Got a negative exponent. Got to change levels. It was on the top, so it's going to go to the bottom.
1 over n, fourth.
Alright, let's do a couple of GPs like this. questions on those?
I see. 5, 2, 5, what? The whole thing is
Anything to the 0 is 1. You probably should put that in your notes too.
I wrote that.
If you haven't already. Alright, let's do some other examples.
Wait, anything to the 0 is 1?
Just did 5 down.
What?
I already did 5.
I don't know why that's a 5. That doesn't make any sense.
Why would that be a 4?
1, 2, 3, 4.
Shut 4 over there.
Because that's not 4.
Oh. Why are you yelling at me?
Oh my gosh, I'm just trying to help you.
Oh, I thought that was
A problem?
Yeah.
I started doing too, then I was like, wait, no, it's not a problem.
Alright. So, at 4 to the negative 2, we need to change levels. It was on the bottom. It's going to go to the top. Become positive. We're going to express this with negative exponents other than 1. Negative 1. With, what's that? With negative exponents other than negative 1. So 1 over 100. Okay. So we got a power of 10, right? Let's start by turning this into 10 to the something. So 10 to the what equals 200? It's not 200. Equals 100.
7. No.
10 times 10, so 10 squared, right? Is 100.
Yeah.
So now we want to make this have a negative exponents. We're going to change levels. And it becomes negative. That skill may help us in the next lesson. We talk about scientific notation. All right, let's do a couple GPs. Let's do GPs like these. So it's this instructions right here. We want to write it as negative exponents other than 1. Excuse me, other than negative 1. These are a little trickier. See what you can make of them.
Let me just make sure.
You can check yourself on the calculator. It's totally fine.
Big one.
8 is pretty easy, right? What's the answer to 8 going to be?
1 over 216?
No. That is not expressed. Guys, you can't just YOLO and punch stuff in the calculator. That's not what the instructions say to do at all. It's not what I say with my mouth to do at all.
6.
Listen with your mouth, read with your eyes. You got this. You want to express this with negative exponents
6 negative 3.
other than negative
6
1.
exponent negative 3.
Yeah. So this would be 6
To
to the negative 3.
to the negative 3.
Right?
Of this 10.
Changing levels and it's becoming negative, right? What about number 9? Can we turn 25 into something with an exponent?
Yeah.
5 squared is 25, right? So 5, 1 over 5 squared. So now if we want to have a negative exponent, what's going to happen? It's going to flip. It's going to become negative.
Oh. Huh? So on 10,
We need an exponent.
I know, but is it 3 as the exponent? Or no?
3 is the exponent. What are you doing to the third?
3 times 9.
Not times. It's got to be some times itself, some amount of time.
Cubed.
3 cubed will give us 27. That's true, because 3 times 3 times 3 is 27. So then it would be 3 to the negative 3. That's the answer. Right?
3 to the 9. Okay. So,
What?
okay. Well, how I see this is,
You see,
you number times the number and try to find how many numbers it needs to go.
Yeah.
Okay.
Alright, let's do another example. And then we're going to do lesson 9.5.
We have a quiz today.
We might have a quiz today.
We have to
Do you have to turn in our quiz?
Why would you not have to turn in
Yeah.
quizzes?
No, well, you have to give us the quizzes from last time.
I will at some point give you the quizzes from last time, yes.
eggs. Football.
So we've done lots of these sort of substitution type problems for a long time. What is going to be our first step?
Parentheses.
Parentheses.
Yeah, parentheses where the variable is. 4 parentheses -5. Then we're going to substitute -2 in there. Okay. So what does that negative exponent do?
Force it. Make it mess it.
What is a negative exponent done this entire class so far? Change levels. So where's it going to go? To the bottom. Now, is the 4 to the -5? Yes or no? No. Only this one. So the 4 is going to stay where it's at. Okay. So what's -2 to the 5th? You can use a calculator if you need to, want to. Don't forget that you need, when you do exponents in your calculator, you need to put that number in parentheses if it's negative.
Negative 32.
Okay. So we've got 4 over negative 32. What can we reduce those numbers by?
By
2.
Even bigger than that, I think.
4.
4. Reduced by 4. What's 4 divided by 4?
1.
1. 32 divided by 4.
8.
So it turns into negative 1/8. It is very important that you show your work. I will not give you credit if you just write negative 1/8. Because I want to make sure that it's this same speech I gave my another class earlier today, Algebra 1. Different type of problem. There are some type of problems where I would give you full credit if you wrote the answer. This is not one of them. Because I want to make sure you know how to do it. I don't care if you can put it in the calculator correctly. I care if you know how to do it. Okay, so you need to show your work on this. Okay. You should do that anyway, because then I can give you partial credit and things like that. All right, let's do 1 GP like this.
1 Jepsy.
And I think we'll do lesson 9.5.
I wrote it wrong.
Then, since you got 2 lessons due now on a Thursday, I'll let you get started on your homework. Because I'm so nice and kind.
Kobe. 1 GB, are you saying?
No.
Ready to go. Is a 3.
So that's only for the 3. The exponent.
What?
Exponent's for the 3.
The exponent is for the n only. That's Make sure you write the problem down too, because if you don't, you write your notes, you're not going to know what in the world this was.
To the negative. Is that how you write it in?
Make sure you put the 3 in parentheses.
Okay.
Well, no, because you want to do the negative part yourself. Do you need to deal with the negative exponent first before you put anything in your calculator?
Oh yeah. It's not negative. No.
Do you add M and N? No. Add it up.
Is 64 when it goes
Do you
top?
multiply the N and M?
Not till you deal with the exponent. Excuse me.
Everything's in bubbles.
Bubbles and bubbles and bubbles and bubbles.
know how to cheat. You can just put 2/4 over 81 and click enter. It's good for you.
That's true. That's true. Your calculator will reduce it for you. Any questions on that problem?
I didn't know that we were supposed to put the 4.
Which 4, sir? This is 4 right here?
Yeah, I didn't know we were supposed
Well, you're substituting it right there. For M, PreAlgebra.
6 on the top end.
I didn't know we were
4
supposed to put it do 6 parentheses 4.
That's the first step. You said that. First step is to write this with parentheses where the variables are.
I'm saying when it's over 3/4.
Is it to the -4? It's a yes or no question. Is it to the, is this to raise to the -4? Where? Where is the -4 right here? No, it's not. So leave him alone. So he stays where he was. Does that make sense?
Yeah.
Good. Good. Good.
The only thing that's touching the -4.
Right. Right. It would have if it was the only way that would be true is if it was like all of this to the -4.
Or like
Right.
parentheses 3 -4 then some reason 4.
Right. Yeah. If it had a -4 on both of them. Yeah. Yes. That too.
That makes sense.
Good.
Somehow I just put both of them on the bottom and then it got 1 2 3 4 5 6.
Craziness.
I got 1 2. I suppose.
All right. Let's do lesson 9-5.
I don't have any more paper.
Wait, 9 5?
Yep.
I can't. I don't have any more paper left.
How do you not have any more paper?
Yes.
Bro,
I'll
you
give
got
you
like a
paper.
bunch more lessons left. You need to get some more paper.
I'll
You need to
give
get
you
your
a
parents to
paper.
go buy you some more paper.
Dad. I need like 3 sheets.
3 sheets.
So I can do my homework.
My core has none.
Actually, I have a lot. I just
I have some sheets.
have all this.
Thank you, young celebrity.
You're welcome, my friend. Why did I get 3 sheets? Oh, here, I get this. Oh, here.
Is this
Oh,
right?
no.
I hate that.
So we're gonna put some we're gonna give some examples of converting from standard notation to scientific notation.
Ooh, coffee.
No, son, I did that. You can just turn your calculator to scientific notation.
The reason why scientific notation exists is because.
Okay, sorry.
Okay, stop saying stupid things and listen to what I'm saying. The reason why scientific notation exists is because of really big numbers and really small numbers. That's why it exists. And it's called scientific notation specifically because in science we have a lot of numbers, things that are really big, think like astronomy, like the universe size stuff, and we have numbers that are really small, think like atoms. And pi is none of those things. Pi is like kind of a normal size number. It's about 3. So.
Pi squared times 1,000.
Alright, so. In standard notation, we can have like the number 147. In scientific notation, this would be 1.47 times 10 squared.
Oh, okay.
Okay, we'll have some examples of how to convert in a minute, right? So you might have the number 1 or 18.12 in standard notation.
Easy math.
We're going to convert that to scientific notation. That would be 1.812 times 10 to the first.
Why should the first? Why does that change?
Well, because the decimal place moved. We'll look at examples of converting here in a second. I'm just getting some examples.
But how do you know on that one? How do you know where it is?
I made these numbers up.
No, like the top one. The top.
What?
No, I understand the top one because it starts at the back.
Yeah. Okay. So, or you might have something like 0.0189, which in scientific notation would be 1.89 times 10 to the negative 2. We just learned what that means, right? Because 10 to the negative 2 is the same as 1 over 10 squared or 1 over 100, right? Right? So you're multiplying times a fraction, which is why it gets smaller, right? Why this number gets little when we're doing that way.
What?
What?
How do you get that?
The negative 2?
Like,
because I know how to convert in my head, but I'm going to show you in a minute.
Yep.
You're going to be able to do it too. Or you might have 0.000508, which in scientific notation would be 5.08 times 10 to the negative 4. Okay, so there's a little chart of examples. Let's look at how to convert and the steps. It's really pretty easy, step by step, straightforward. It's not actually very hard. It really is easy. I'll show you.
Where are you getting the 10?
Yes.
get smart.
Oh, that makes sense. Oh, I thought
Okay,
I was
let's do some examples. So we're going to convert. We're going to start by converting from scientific notation to standard form. So examples.
Oh, 1-1.
Express each number in standard form. So the first example.
Number uno, watch red.
Is 2 times 10 to the third. So, because this is positive, are we expecting a big number or a little number?
Big.
Big number, right? And so that's people. You'll see this if you go watch other videos or other classes or whatever. They'll say you need to move to the right or to the left or whatever. I think it's a lot easier if you think about it. I'm expecting a big number or a little number. Because then that tells you what direction you're going to move the decimal point. So step 1, ready? Step 1 is to write this number without the 10 with a decimal. Make sure you put a decimal point where the decimal point is. So in this number right here, where is the decimal point?
After.
Yeah, it's after the 2. It's invisible right now, but we're going to put it in there. So 2 point. Okay? Then we're going to bounce. We're going to make some bubbles. We're going to make 1, 2, 3 bubbles.
Circle.
Okay? So we're going to go 1, 2, 3 bubbles. And that's where the new decimal place is going to be. Okay? If we made bubbles that are empty and don't have any numbers, we add zeros in there. So this number
2000.
is standard form is 2000.
Wait, can you do 2 times 2 times 2 times 2 times 2
That would not be 2,000. 2,000 is not a power of 2. You could do 2 times 10 times 10 times 10, but you know, this is much easier. Alright, let's do another one. 6.8 times 10 to the 5th. Okay, so we're going to write our number. Make sure we include the decimal place.
So it'll always be 10?
10.
Yes.
Okay.
And then we're going to do 5 bubbles. 5 bumps. So starting at the decimal, we expect a big number because this is positive. So 1, 2, 3, 4, 5.
6 million.
And then we add zeros where there's empty bumps.
100,000.
No, 680,000.
I told you so.
You definitely did.
Failure.
I did it in my mind.
Oh, well, your mind and your mouth broke because what came out of your mouth is not that. Okay. Alright, let's do one more.
The roses. This is the number.
So that this is kind of so just be a normal number like that.
On these kind of problems, we're going to express it in standard form, yes. 3.25 times 10
to the 8th
to the negative 4.
Negative 4.
Okay. This time we're multiplying times 10 to the negative 4. So we're expecting a big number or a little number? Little number, right? Which means we'd be moving our decimal place this way, because that's going to give us a little number, right? So we're going to do the same steps, really, right? We're going to write our number down with the decimal point.
0.000.
And we're expecting a little number, so we got to go this way, because that's going to give us a little bitty number, right? So we're going to go 1, 2, 3, 4. Now, this is very important, right? When we went this way, put our new decimal point there, we've got to add this 0 in front, or else he's ugly, right?
Super ugly.
So 0.0000325. Say that number out loud correctly.
0.000.
No, that's not right.
0.325.
No, that's not right either.
0.35. No. Can you tell us?
325 millionths is the correct way to say that number. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions.
0.32.
Okay. Let's do some examples going the other way. We're going to express each number. Go ahead and start writing that in scientific notation.
Express EA.
Scientific notation.
No.
Okay.
It's called dividing by 5.
5. What?
Yes, get it right.
Okay.
Comma 0, 0.
So, this is what we do. We need to find where the decimal place is. Where is the decimal place?
I mean, at the end.
At the end. It's right there, right? So, we need to do the decimal place. Now, then what we need to do is we need to do our bumps. And we do our bumps until we are to the right of the first non-zero number. Okay? So we're going to go 1, 2, 3, 4, 5, 6. Okay?
6. I know it. I know the answer.
What is it?
So it is 4.0
to the 6. Oh, 4.
times 10 we start with a big number or a little number?
Big.
No, we did not start with a little 4 million. The number. We start with a big number.
That's
So
so tiny.
to the 6th.
Oh my goodness.
You're not rich.
How do you know?
Okay.
I do. This is the easiest lesson.
Is it?
Right. 5,800.
5,800.
Okay. So where is the decimal place?
At the very end.
Very end. Same idea, right? So we're going to start with the decimal place, and we're bouncing once, twice, 3 times. To the right of the first non-zero number, right?
Actually,
that's this one.
Actually, the answer to this question is 58.0.
No, it's not.
It's 5.8 times 10 to
Seconds.
5.8 times 10 to the third.
That's what I said.
Actually wrong.
Why is it 3? Oh, but that's the first number. You said to the first.
The right of the first non-zero number.
Which is the first non-zero number. That's
the leftmost. Is that a better word for you?
No.
the leftmost.
Leftmost non-zero number. All right. One more example.
I've never been to the left.
Okay. That makes more sense.
0.072.
0.072.
Okay.
There isn't one. Oh,
there is one. It's right there. It's the first one that's been visible.
2.
Okay.
So it's 7.
That's what I said.
So we start at the decimal and we move to the right of the leftmost non-zero number. Now, do we start with a big number or a little number on this one? Little number. So it's 7.2 times 10 to the negative 2.
You're not that smart.
Joe.
Since the person that said this was the
I'm stating facts.
Easy peasy?
Yes.
The limits.
Okay. Y'all go ahead and get started on your homework. You do? You want to do that now?
Yes.
Okay, let's do it.
What do we have to do?
Dad?
You have to start your homework, Gordon.
Dad, can you sign these?
Huh?
Can you sign these? You're my parent.
Can I sign what?
My grade sheet.
Which grade sheet?
9. These are 9. Grade sheet.
Wait,
This
both
grade
of
sheet.
them?
You've done the homework?
Yeah, I've done all these.
Yeah, both of those are due on Thursday. That's why you're having time to start now.
Sweet.
5:02.
Oh, just a few minutes ago. Probably just missed it.
No, not this.
You realize I went back in shoe.
Like,
Oh, I do have something to get back to.
I'll see.
Me?
There they are. I found them. I knew they were here.
So it's negative x.
Right.